Hello everybody, welcome to Light the Deep. The holy grail of AI right now isn't an LLM that is hosted on a massive server farm in the cloud, as they are generic and also data privacy is a huge concern. It is the small models that live entirely on your laptop, completely private, zero subscription fees, specific to your needs that change the game. But if you tried running local models, you know that they crash your computer, that is, your GPU is out of memory, or they are very dumb or they are not smart enough, they hallucinate very often. But today we are looking at Qwen 3.5, a foundational rewrite of how neural networks handle memory, vision and language, and how close we are to get to a model that is just right. Historically, running a powerful small language model slammed you into two massive brick walls. Wall 1, the memory explosion wall. When you feed the LLM a long document or a complex dataset, the model's intermediate state information, that is the keys and the values, rapidly consume all available memory that is there in your GPU. So your RAM maxes out and leading to slow processing times or often a complete system crash, that is Python or out of memory error. Wall 2, the adapter bottleneck. Every time you give an AI an image or other non-text input, that is like audio, it has to squeeze the data through a slow separate translation layer that is called the adapter, which we'll see on later. This process severely limits the speed of the multimodal understanding, causing the AI to lose fine-tuned detail from the input and wasting significant computational power. We'll see more in detail. Alibaba just didn't release one model as in the Qwen 3.5 lineup. It has a series of multiple models in multiple various sizes. So they dropped an entire ecosystem, if I had to say in a better word. So there is a 397 billion flagship server farms and 122 million medium for workstations. But today we ignore the giants and zoom into the highlighted section, that is the small tier. These are the models, that is 0.8B, 2B, 4B and the 9B. These are the small language model tier, and these are the things that you can run on your consumer PCs and workstations. These are the things that we are going to be focusing today. Think of the four models like cars. The 0.8B is a scooter for your phone, fast and light. A 2B is a compact car. The 4B, that's 4 billion, is a SUV. And the 9 billion, a sports car that still fits in your garage, a Mazda Miata if you will. Instead of your garage, it's going to be in your MacBook. Now, how can a phone-sized LLM read a 300-page PDF and process images natively without the slow translation layer? To answer that, we need to understand the two engineering walls. Let's jump in. Every LLM since 2017 has been using the same core memory mechanism called attention. From GPT-2 in 2019 through the GQA era in 2023, there are slight modifications here and there, all the way up to Qwen 3 in 2025. Attention was still the gold standard, and it maintained the massive weight behind the intelligence of the LLMs. But it also maintained the biggest memory bottleneck in consumer AI history. Now let's jump in and see what the attention is all about. Now, as we saw in earlier videos, standard attention in plain English, every time you read a new word, the AI writes it on a separate sticky note and places it on the VRAM shelf. Read 10,000 words, the 10,000 sticky notes. 40 plus gigabytes of RAM, then just to hold all of them together. Feed a standard model a 100-page PDF and your system crashes. That's the memory wall that I'm talking about. Researchers fixed it with group query attention that was used in Qwen 3 and models like it. Instead of a sticky note per word, you group several words into one shared folder, like a filing cabinet instead of a sticky note storm. It cuts memory roughly by 4 times. It's a real breakthrough, but it had a fatal flaw. The flaw is that GQA only delays the bleeding. It does not stop it. Even if your filing system, you are still adding folders. After 10,000 folders, the cabinet is full. Feed a GQA model a 300-page PDF and the KV class still explodes. It scales linearly. Band-aid is not a cure. So the linear scaling still hits the wall at some time. So we need something that can scale constantly. Now, if you consider GQA a band-aid, then Qwen 3.5 is a surgery. GQA has been completely ripped out of the small tier and been replaced with something very radical, the Gated DeltaNet. This single architectural change makes infinite context on a laptop not just possible, but absolutely real and practical. Let's open the hood. The moment tokens enter DeltaNet, they do not rush into the memory. The queries and keys first pass through it. A one-dimensional convolutional layer and then a L2 normalization. The sliding spell checker that groups nearby words into local context before the memory system ever sees them. less redundancy. First reason DeltaNet is so efficient. Now the real magic, the gated delta rule. You're a student in a 3-hour lecture. Standard attention is basically going to write every single sentence on a new piece of paper. 500 pages by the end. DeltaNet is the great student. So that thing keeps one page of running summary notes. Here's something new, update the summary. Don't add a page. Old info that is no longer relevant gets gently overwritten. Memory stays fixed size no matter how long the lecture. That's the delta rule. You know the input gate, the forget gate and the output gate of the LSTM. Now what happens if you combine LSTM and with some parts of transformer, and that's what you get. That core of the LSTM is called the delta rule. And that's how we literally thrash into the fixed context size, fixed memory usage. Now you may think, if you are constantly overwriting the summary, how does the AI know what to keep and what to forget? Now here comes the 3 mathematical gates, the bouncers of the club, the same forget gate and the input gate I talked before. The sigmoid decides in or out, 0 means blocked, 1 means enter. CLU controls how strongly the new data overwrites the old. Soft plus ensures nothing is fully erased. You always keep a trace of something, whatever happened. Together, precise, trainable memory control that is always fixed in some bound length so that it doesn't overflow and break your VRAM. Now, here's the experiment that we ran. The x-axis is the context length and the y-axis is the RAM in gigabytes. The blue line is the GQA, the standard that Qwen 3 uses, and the mechanism that Qwen 3 uses. We have just taken that part and we are going to see what it is. So if you feed it more text, the RAM usage climbs to 40, 50 gigabytes and slowly it goes to the crash finally. Now watch the orange line. This is the gated DeltaNet alone. Now it's completely flat. Feed it 1000 tokens or a million tokens, the memory never moves, infinite context for free. That's just, now it's inevitable, right? Let's use gated DeltaNet all in. Why not go all in gated DeltaNet? Let's see why. There is a trade-off in gated DeltaNet. The fixed summary approach is a brilliant thing for memory, but the standard full attention is still vastly superior for the complex multi-step reasoning, and that is the essential reason why people replaced LSTM with attention and language models, large language models. Now we have come a full circle back into LSTM. So, but we need to somehow merge these two to get something just right. And that's how we are going to really do some physics problems here. So what do? Let's use both. Let's merge both together. Let's use some parts of this and some parts of that to get things just right. Now what is just right? Let's see the ratio. Now turns out that just right ratio in what Qwen 3.5 uses is the 3:1 hybrid ratio. 3 librarians who read and summarize every book, that is 3 gated DeltaNet users, and 1 brilliant analyst who only reads the summaries for the genius answer, that 1 attention layer. Now 3 DeltaNet layers do the heavy lifting, reading the entire document at 0 memory task, and the 4th full attention layer does the deep reasoning and the compressed knowledge, infinite memory of RNN plus the IQ of a transformer. Now you have very good, intelligent but memory efficient model. That's Qwen 3.5. Now while talking about Qwen 3.5, I want you to note something very deep. There is something, a mixture of experts that is also going on around. But we need to really remember that the MOE routing only applies for the flagship and the medium sized models, not for the ones that are being categorized into the small category. That is 0.8B till 9 billion. They are all entirely dense. There is no routing, there is no expect selection, just 3:1 DeltaNet hybrid, critical for development and quantization choices. So I want you guys to be very clear that the small models are dense models, while the medium and large models are the ones which have the MOE. Because there are images that are going around with Qwen 3.5, MOE, all of that architectural changes are being mentioned. But be very clear that the small models are not MOE models but are dense. Now Qwen 3.5 is not only about the gated DeltaNet, it's about more stuff. Now let's look at language. Most SLMs are trained on up to 95% English data. That means the LLM has never learned about the broader world thinking capabilities, which secretly make it a dumber model than it could be. Now Qwen 3.5 is taking this head on. You may ask how. The multilingual race is a war zone, and Google is the leader of the pack until now. Like Google's Gemma 3 made waves with the 140 plus language a genuine achievement. But Qwen 3.5 fired back with the support of 201 languages, specifically target low resource language big tech usually ignore, like Swahili, Welsh, Bengali and hundreds more. 201 versus 140, the scoreboard is very clear. Qwen 3.5 all the way. Now, just training around 200 languages, is it enough for you to get a very good language model? Not really. Now, Qwen 3.5 uses a vocabulary of 250,000 tokens. Think Lego. With only 50,000 bricks, you might have to chop foreign words into tiny meaningless fragments. But with 250,000 bricks, almost every word in almost every single language in the world gets its own brick. No fragmentation, no wasted compute, fluent reading in any script. This is what Qwen 3.5 achieved. But many of you guys will be thinking, now what is so great in achieving language superiority? But here's the straight thing that most reviewers miss. Why the 201 language thing that the Qwen 3.5 trained is going to make the model think better in normal use cases. How? Because in neural networks, language is equal to logic. Forcing a 2 billion parameter model to understand Japanese ordering and Turkish word construction and Mandarin tone simultaneously makes it stop memorizing English patterns and start building an abstract model of the world. Multilingual training is the secret intelligence in training. It makes the model understand the world in semantic and latent space and properly construct meaning out of it. Now let's come to the second wall, the vision adapter and the adapter layers. The older vision language models like Qwen 3VL, that is of the last generation, used a vision adapter architecture. The image arrived and got processed by a separate vision encoder like VIT and then got shoved through the adapter bottleneck layer to translate it to text tokens. So basically somebody was handling getting an image, converting it into text, that is translating the entire image into text, and then that is getting fed to the LLM. But this is like speaking with a translator on, right? If you don't understand my language and I have to speak through a translator, the translator remains the bottleneck. The speed and accuracy of him is going to make the main focus of the conversation between us. Similarly, here the adapter is going to be the bottleneck of the how much better the model is able to understand the images that you feed. Now, Qwen 3.5 drops this architecture and goes on to a unified architecture. So Qwen 3.5 ripped adapter entirely, and now unified vision models breaks images into patches and treats them as exact same native tokens as text. So as there are tokens that represent for each text and each word, there are tokens that can represent patches of the images. So now like that for audio too, or any other non-text format. So text and audio and image directly flow to the LLM directly, therefore there is absolutely no loss of information. They directly are routed to the DeltaNet and attention layers. There is no translation, nothing is lost. The AI thinks in pictures and words simultaneously, giving a dramatically better reasoning in charts, diagrams and high resolution photos. There is a wall 2, that is the adapter wall, has been solved completely right now. And for those benchmark folks out there, there's this benchmark that proves it all. So the GPQA Diamond, the graduate level reasoning in physics, biology and chemistry, is not a chatbot quiz. It's a proper benchmark where you can test your model's intelligence on. This Qwen 3.59 billion scores 81.7, beating open source Jane more than 10 times its size, like GPT versus 120B, Llama 3.3 70 billion, and the engineering trinity, Gated DeltaNet, 3:1 hybrid and 201 language training compresses the intelligence that used to require a server farm into something that fits into your laptop bag. Yes, believe me, the 201 language thing is actually giving it more generalization, that thereby actually boosting its benchmark. That is something that we generally miss, but it's something that's also important. So that's it for this Qwen 3.5. Please check out the model and do tell the feedback in the comments below. And let's jump out. By killing GQA and flattening memory curve with Gated DeltaNet, mixing it onto 3:1 ratio, ripping out the vision adapter and replacing with the unified native token stream, and training on 250,000 token vocabulary across 201 languages, Qwen 3.5 small lineup is a masterclass in software engineering. The days of needing server farms for complex AI are ending. If this breakdown helped, smash that subscribe button, drop a comment on what the architecture to cover next, and I'll see you in the next one.